Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through everything you need to know for your upcoming test. So let's start with Pythagoras and trigonometry. So both of them are looking at right-angled triangles. I'm sure you know what one of those is by now. So we have a right angle, and we call the side facing the right angle, which always happens to be the longest side of the right angled triangle, we call that the hypotenuse. Now, Pythagoras and trigonometry both sort of have the same goals, trying to find a side, or in case of trigonometry, an angle, using information already given. Written on your screen when you can use Pythagoras and when you can use trigonometry. So they're sort of complementary. So you can use them under different circumstances. So Pythagoras only involves sides, never involves angles. So you finding an unknown side when you know the other two sides of the right angle triangle. And trigonometry, you can also find a side, but rather than knowing two other sides, you need to know one side and one angle. Trigonometry, unlike Pythagoras, you can also use to find an unknown angle in a right angle triangle, and you need to know two other sides for that. So make sure you're familiar with this. When you're sitting in class and you're doing work from the Pythagoras exercise, you know all those questions involve Pythagoras. When you're doing the trigonometry exercise, you know they all involve trigonometry, but when you come to a test, you're going to need to be able to decide, do I use Pythagoras or do I use trigonometry? So Pythagoras, as I said, doesn't concern angles at all, but in order to use trigonometry, we have to have a reference angle, so I'm just going to call that angle theta. And we also have to label the other two sides. So the side facing angle theta, we call that side opposite. So that side is labeled opposite angle theta. So the other side, which happens to be next to theta but not the hypotenuse, is called the adjacent. So the opposite and adjacent sides are always the shorter two sides of the right angle triangle. So they actually can switch around if we switch around the reference angle. So what I mean by that is if I draw another right angle triangle similar to the one above, but now I'm referring to this angle, so I'll call it alpha. This side is still the hypotenuse because it's facing the right angle. It is the longest side of the triangle. But now the side facing the angle is down here. So this side is now the opposite and this one the adjacent. So they switch around depending on where the reference angle is. You need to be able to label sides appropriately if you are to successfully use trigonometry. So now we're just going to do a few basic examples where we're calculating unknown sides and angles. Please pause and copy this down if you need. So let's say we have a right angled triangle like this and we want to find x. So x is a side. We have one angle and another side, so we must use trigonometry. Now, when you're using trigonometry, remember the acronym you need to know is SOHCAHTOA. That acronym gives us the first step of finding an unknown side or angle using trigonometry, as it tells us which of the three ratios to use. There are three ratios. So it stands for sine is opposite and hypotenuse. So if the question involves the opposite and hypotenuse, use sine. If it involves the adjacent and hypotenuse, use cos. And if it involves the opposite and adjacent, use tan. Now, sine, cos, and tans are ratios, so they're something divided by something. The first thing goes on top, and the second thing goes on the bottom. So, for example, for sine, it's sine theta equals, so sine of the angle equals the opposite on top, hypotenuse on the bottom. We know that because opposite is first, it goes on top. And that's precisely what we're going to use in this question here. So we have sine of the angle equals opposite over hypotenuse. Okay? So let's take a look at another example before we solve this, because I want to show you the difference between them. So let's start up with another triangle. So let's say we have this triangle here. So we have our reference angle. X is next to it, but not the hypotenuse. So X is adjacent and 10 is facing it. It is the opposite. So opposite and adjacent, we use tan. So we have tan of angle equals opposite over hypotenuse. Again, we're trying to find X. So in these questions, we do them slightly differently. What makes them differently, apart from using a different ratio, is that you can see in the first triangle, the X, the thing we want to find, is on top, whereas in the second one, the X, the thing we want to find, is on the bottom. When the thing you want to find is on top, you times. So in this first one here, X is 12 times sine 30. And if you put that on your calculator, you get 6. You've got to make sure your calculator is in degrees mode. Please ask your teacher if unsure about that. So that sort of makes sense. X is one of the shorter sides of the triangle. It has to be less than 12. So since we got an answer less than 12, we know we've done something right. So when the thing you want to find is on top, you times. When the thing you want to find is on the bottom, you divide. So for this one here, it isn't X is 10 times 1052. It's actually X equals 10 divided by 1052. And again, it's really important that you have your calculator in degrees mode. So if we put this in our calculator to 2 decimal places, we should get about 7.81. So of course, first one was centimeters and the second one is meters. How easy is that? Let's look at finding an angle using trigonometry. So let's say we have this triangle here. Now finding an angle this time, because the unknown thing is theta. So it's very similar to finding a side. We use the same ratios. So here we have the adjacent and the hypotenuse. So using the soccer toe acronym, I need to use cos. But because this is an angle, instead of using cos, I actually use cos inverse. So rather than setting up an equation, I can sort of go straight to the answer. So theta will be cos, because it's adjacent and hypotenuse. Cos inverse, that's what the -1 means, because I'm finding an angle. And again, it's because in soccer toe we have cos, C-A-H, A comes first, meaning the adjacent goes on top of the hypotenuse. So I just put cos inverse of 4/5 on my calculator. To do that, I press second, then cos, and then type in 4/5. And the answer I get should be about 36.87 degrees. So how easy is that? In fact, finding an angle tends to be easier when using trigonometry, because we don't have to contend with is the thing we want to find on top or on bottom, and so we won't mix that up as people often do. So let's look at another example. So in this new triangle, let's try and find C. So note here, we don't have any information regarding angles. Therefore, we can't use trigonometry. Remember, to find a side using trigonometry, we need a side and another angle. But we do have the other two sides. And in this situation, we use Pythagoras. If you know two sides of a right-angled triangle, you can use Pythagoras to find the third. So you probably know that Pythagoras' theorem is a squared plus b squared equals c squared. That's what Pythagoras is. However, it might be worth your while to go sort of straight to the answer rather than solving an equation. So you can use these formula. So C, when we say C here, we mean the hypotenuse, the longer side, is just the square root of a squared plus b squared. That's just rearranging the red equation on top. So that's how you find the hypotenuse, which is the longer side. If you're trying to find a shorter side, the formula is very similar, except you have to minus. So note there's a minus here when we're finding the shorter side, but there was a plus in there when we're finding the hypotenuse. So in our question here, we're finding the hypotenuse, the longer side, so we plus. It will be the square root of 6 squared plus 8 squared, which happens to equal 10. Okay, let's look at another example. So let's look at this new triangle up here. So we have another right angled triangle. We know two of the sides, so we can use Pythagoras to find the third. But this time we're finding a shorter side. It doesn't matter that the shorter side is called y. We can still use this formula. So y is just going to be the square root of 12 squared. Now this time, because we're finding a shorter side, we need to make sure we subtract. It's really important that you have the hypotenuse first when finding the shorter side. If you try to do the square root of 10 squared minus 12 squared, thereby mixing them up, you'll get an error in your calculator because you can't square root a negative. So this first one here has to be the hypotenuse. So we end up getting the square root of 44. That's the exact answer if you've seen that terminology, or you can just write it as it's about 6.63. Okay, there's no units written, so just write U for units. So when you're finding Pythagoras, you can jump straight to the answer like that, except in one type of question, which I will go through now. That happens to be when you're finding two unknown sides at the same time. So let's try this question here. Length of the hypotenuse of a right-angled isosceles triangle is 10 centimeters, and we'll find the length of each of the shorter sides. So you might be thinking, well, hang on a minute, don't you need to know two sides in a right-angled triangle? Well, this is an exception. Because this triangle is isosceles, its two shorter sides are the same. So let's draw it. It'll be a right-angled triangle, but because it's isosceles, two sides are equal. You can't have one of the shorter sides equaling the hypotenuse, so these two sides must be equal, and the hypotenuse is 10 centimeters. Now we can figure out these unknown sides, so I'll call them both x, by using the equation. We can't jump straight to the answer this time, just put straight in our calculator square root of blah, blah, blah. We have to write it out. So a squared plus b squared equals c squared, and we solve it from here. X squared plus x squared, collecting like terms, gives you 2x squared, and then 10 squared is 100. We've got to solve for x, undo everything that's been done to x. So what we're going to do is divide each side by 2, because remember, we have to undo things in the opposite order to BIDMAS. In BIDMAS order of operations, this comes first. Squaring comes before multiplication, so we undo that last. We undo the multiplication first, then we undo the squaring. So 2x squared divided by 2, 100 divided by 2, and if x squared equals 50, you undo x squared by square rooting. So you get x is the square root of 50, or about 7.07. So each of these sides, this one here and this one here, will be 7.07. So in this particular question, we could have actually used trigonometry, because in a right-angled triangle, each of these sides will be 45 degrees. I just showed you using Pythagoras, each to their own. Now we're going to continue by showing you a bit more of the trigonometry you need to know. So we also learned applications in 2D. That's where you take a problem in 3 dimensions and make it into 2 dimensions. The main thing you learned here was about angles of elevation and depression. So remember, if you have like an object down here and it's like looking up at an object, say, in the sky, so that's another one up here, we need to know about the angle of elevation and depression. So what we can do to use trigonometry is draw some right-angled triangles and find unknown lengths and angles. So this angle here is the angle of depression. It's the angle looking down, depression meaning down, and then its counterpart is down below is the angle of elevation. That's the angle of looking up. So note, the angle of depression and the angle of elevation are the angles made with the horizontal. They're always equal to each other in value because they are alternate. So if we have a right-angled triangle, we can use this to find unknown lengths. So I'm just going to do one quick example of this. So we're going to have a go at this question here. Person stands 10 meters from the base of a tree. Angle of elevation, 77 degrees. We'll find the height of the tree. So we're going to disregard the person's height, because otherwise we have to get into, is the angle of elevation from the person's eyes or from the ground or whatever. We're just going to ignore that for now so that you can learn this. So if you're not given a diagram, start by drawing one. So what we have is we have a point here where the person is standing, and that's 10 meters away from some tree. So I'll just draw the tree here. Okay, so we can't find any unknown sides or angles if we don't have a right-angled triangle. So we need to turn this into a right-angled triangle like that. So we want to find the height of the tree. Now it tells us the angle of elevation to the top of the tree is 77 degrees. So that's actually this one here. Okay. So of course the angle of depression from the tree, which would be that one there, would also be 77 degrees. So now we have a right angled triangle, we have an unknown side and to find here, which is x. We have the value of another side, we have an angle, and so we can simply use trigonometry. We have the opposite, which is the side we're trying to find, and the adjacent, so we use tan. So tan 77 equals opposite over adjacent. If the thing you want to find is on top, then you times. So x is just going to be 10 times tan 77. And the answer you get there is about 43.31 meters, again to 2 decimal places, all right? So now we're going to go through the other type of application that you learned, which is bearings. So bearings help us know about the direction in which something has traveled. You can use words to describe it, but that's not precise enough. So for example, you might have a plane that starts here. You might say, hey, it's gone northwest. Well, that could be in this direction, or it could be in this direction. Now, they may seem very close to you, but when we're talking about something like a plane, if it's gone in only slightly the wrong direction, it won't reach its landing destination. You know, if it's a plane coming to Canberra, it won't quite reach the airport. It'll, go over Canberra City and have nowhere to land. So it's important we use numbers so we can definitively decide in which direction an object has traveled. So how do we do that? Well, what we do is we have two axes similar to the Cartesian plane. Now, you're probably already very familiar with north, east, south, and west. So what we do is we give each direction a number. So different directions have a different number, so there's no way to get them confused. So how do we decide on that number? Well, we've decided on a convention. It's always the angle made with the north axis going in a clockwise direction. So clockwise, of course, following a clock. So if you don't know what that means, it's going this way, okay? So that's how we determine a bearing. So for example, if I went in this direction, in this angle's 30 degrees, the bearing's just 30. We usually give it 3 numbers, and we write degrees T for true. Okay, that's pretty simple. But what about if you went in this direction here, and this angle was 30 degrees? Well, this red bearing, we don't want that to also be 30 because that would be ambiguous with the green bearing. So we write the bearing as the angle made with the north axis going clockwise. So we don't want this angle here, which is the one marked in red. We actually want this angle here. So what would that black angle be? Well, we know that north and east are at 90 degrees. So east would be 90 degrees, and then south would be 180 degrees, west would be 270, and then back at 0 or 360 degrees would be north, right? So we know that this whole angle there would be 180. So this angle in black would be 180 minus 30. So it would be 150 degrees true. Let's say I wanted to go in this direction, and I'll just say that that angle there is 45 degrees. Again, I don't want to just call that 45 because that's ambiguous. What I want to do is I want to find this angle here. Angle made with the north axis going clockwise. So this angle here would be 270 all the way there minus 45. So it would be 270 minus 45, which is 225 degrees true. And the last one I'll show you in the fourth quadrant. So let's say I go in this direction and this angle here was, say, 20 degrees. Again, could be ambiguous, so it's the angle I want is the angle made with the north axis going clockwise. So I'm talking about this angle all the way around. So that is 360 minus 20, and that will be 340 degrees. So now that we know what bearings are, let's do a couple of questions involving them. So this is the kind of question we might do. I travel 12 kilometers on a bearing of 222 degrees. How far west am I from my original starting point? So as I said earlier in this video, if you're not given a diagram, draw one. So pick your starting point, and it's always helpful to draw a little set of axes here, like a compass bearing there. So 222 degrees. Firstly, which direction's that? Well, we know that we start at the north axis going clockwise. That's 180 degrees. 180 degrees is due south. So 222 degrees, I need an extra 42 degrees. So I've gone in this direction, and this angle in here is 42 degrees. It's 222 minus 180. Now, I can't solve for any unknown sides and angles if I don't have a right-angled triangle, so I'm going to turn this in to a right-angled triangle. Now, I was told that I went for 12 kilometers, so that's the black line there is 12 kilometers. Now, how far west? So I started here. How far west is this distance here? And I will call that X. So that's the hard part, drawing the diagram. Now I've got that. I've got a right-angled triangle, and I just need to find an unknown side, and that's easy. So X is the opposite side. 12 is the hypotenuse. So, katoa, SOH, I use sine, because I have opposite and hypotenuse. So sine of angle equals opposite over hypotenuse. When the thing you want to find is on top, you times. So it'll be 12 times sine 42. Again, make sure your calculator's in degrees. Put that on my calculator, I get about 8.03. In this case, it's kilometers. Again, the answer I got should have been less than 12, since 12 was the hypotenuse, so I know I've done something right. So a worded question should have a worded answer to show that you know exactly what you found. So therefore, I am 8.03 kilometers west of my starting point. So I just want to do one more question now, this time where you know the distances but have to find the bearing. So let's look at this question here. I must travel 8 kilometers east, then 6 kilometers south, and find the bearing on which I must travel to return to my starting point. If you're not given a diagram, draw one. So we're going to go 8 kilometers east when we start here at the dot, then we go 6 kilometers south. So again, south and east are at right angles. We need to create a right-angled triangle. Otherwise, we have no chance of solving this. Okay, so on what bearing? So I've ended up here. This is my finish point. So firstly, I need to find this angle theta. So 8 is the opposite, 6 is the adjacent, so I use tan. Because I'm finding an angle, it's tan inverse. So theta equals tan inverse of opposite goes on top of adjacent, because it's TOA, T-O-A. O is first, O goes on top. So if we put this on our calculator, we should get about 53.13 degrees. So you're probably tempted to think, okay, cool, that's the answer. Well, no, that's not the bearing, because remember, the bearing is the angle made with the north axis going in a clockwise direction. So let's put a compass here. So the bearing is not 53, it's 360 degrees there minus 53.13, because we need to travel in a northwest direction to get back to where we started. So therefore, the bearing required isn't 53.13, it's 360 minus that, which is about 306.87 degrees. That is the bearing required. So please understand, just because we found an angle doesn't necessarily mean it is the bearing. All right, we're now going to go on to measurement. Okay, so you probably know how to find the area of most things. So I'm not going to go through examples of how to find, areas of every single shape, because you probably know how to do that by now. I'll just go through a few that have caused problems. So first off, trapeziums. For some reason, people find them very hard to find the area. So a trapezium is a four-sided shape with one and only one pair of parallel sides. So what you need for this is you need the two parallel sides and the perpendicular height. So if we have something like this, we use the formula for a trapezium, and that is area equals h over 2a plus b. So a and b are the two parallel sides. H in any formula in measurement, whether that be area, surface area, volume, whatever, it always means the perpendicular height, not the slant height. So in this case, the area of this shape would be perpendicular height divided by 2 times the sum of the two parallel sides. You can put that on your calculator and you end up getting 90. So the area is in square units. How easy is that? So another shape that's caused us a bit of problem is a sector, so I'll now show you that. So a sector is a part of a circle. It's like a slice of pie cut out of a circle, although it needs to go to the middle of that circle, to the origin. So what we do is we find the area of the whole circle and then multiply by the fraction of the circle we have. So the area of a circle is pi times radius squared. So if we have part of a circle, we look at the angle in the middle. So we know that a full circle has 360 degrees. So what we do is we take theta, the angle that we have in the middle, the angle of the sector, and divide by 360. That tells us what fraction of the circle that we have. So in this case, because the angle's 35 degrees, we have 35 over 360. 35 3/60ths of the circle, and we're just going to times that by pi times radius squared. And if you put that on your calculator to 2 decimal places, you get about 51.62. And of course, it's centimeters squared. Okay, so we did a little bit on area, but that was more so you'd get what you need in order to be able to do surface area and volume. So we're now going to look at that for a variety of prisms. So let's look at this shape here. This is a rectangular prism. So for those who aren't doing the 10A test, those who are just doing the normal test, we're only looking at surface area and volume of 3D shapes being prisms. We're only looking at prism shapes that have a consistent cross-section, if you like the top and the bottom are the same shape. So we're only looking at those shapes. So we're going to start off with total surface area. So the surface area of any shape, whether prism or otherwise, is just the sum of the area of all its faces. Think of it as if I wanted to wrap up this rectangular prism in wrapping paper, what is the minimum amount of wrapping paper I need? What is the smallest area of wrapping paper I would need to wrap this up? So it makes a difference whether this shape is open or closed, because what makes surface area a little difficult is we have to adjust if, say, the top is not there or the bottom's not there or whatever. So in this case, I'm just going to tell you the shape is closed, meaning that we have to include all of its faces. Now, a rectangular prism has 6 rectangular faces, so we just find the area of each and add them up, but they come in pairs. So here the top and the bottom are the same size rectangle. The front and the back are the same size rectangle, and the 2 sides are the same size rectangle. So if we look at the top and the bottom, so this one here, that is 6 by 12. So we have a rectangle that's 6 by 12, but there's an identical one on the bottom. So that's why we times it by 2. So we then need to add the other rectangular faces. So at the front, we have 4 by 6, but the one here at the back would also be 4 by 6. So that's why we times it by 2 again. And then finally, we have to include the one at the side. So that is 12 by 4, but again, there's another one of those on the other side. So it'll be 2 times 12 times 4. And that's how we get the formula for surface area of a rectangular prism is 2 length width plus 2 width height plus 2 length height. Okay, and you are getting a formula sheet on your test anyway, so you don't need to memorize the formula. You just need to know how to do this, how to use the formula. Okay, so let's put all of this onto our calculator, and we should get 288. It is square units because it's surface area. Okay, how easy is that? So that's the TSA, total surface area. So the volume is the amount of 3D space inside this shape, because it is three-dimensional. It has length, width, and height, or length, width, depth, whatever you want to call them. There's 3 of them, 3 dimensions. So the volume's really easy. We don't have to account whether or not it's a closed prism. The volume of any prism is the area of base times the height. Now, please be careful. People always think the base means the bottom. It's not necessarily the shape at the bottom. It's just the cross section. It's the shape that is repeated. So for the rectangular prism, you can literally view any of the rectangles as its base. So the base of this, I'm going to say, is 6 times 12. That's the bottom rectangle, and we times by the perpendicular height, which is 4. So the volume of any prism is area of base times the height, but for a rectangular prism especially, you might like to use the formula length times width times height. You just multiply the 3 dimensions together. So 4 times 6 times 12. So 24 times 12 actually gives you 288. Also, that was just a coincidence. You don't always get the same number for surface area and volume, but this will now be centimeters cubed. Volume is measured in cubic centimeters. So you might be asked about the capacity of this. How much liquid could it hold? So the only difference between volume and capacity is the units. So the volume is 288 centimeters cubed, but note that a centimeter cubed is exactly the same as a milliliter. They are the same thing. Your Coke can holds 375 mils. That means you can fit 375 cubic centimeters into it. So the capacity of this shape is going to be 288 milliliters. That's how many milliliters of liquid it can hold. Okay, so now we're just going to look at a triangular prism. So let's find the total surface area and volume of this triangular prism here. So a triangular prism has a triangle as its base. So this shape here, this triangle here is the base, not the rectangle at the bottom. That is not the base. So to find the total surface area, now we can't really give you one for a triangular prism. We can't give you a formula that is. The reason being because the formula would be different if the base triangle was equilateral, or if it isosceles or right-angled or scalene. There'd just be too many different formulas to remember. So you need to approach each formula slightly differently. So what would be better than giving you the formula is for you just to know that every single triangular prism has 5 faces, 2 triangles and 3 rectangles. So just find the area of each of those, then add them together. So, total surface area. So we'll start with the triangles at the front and the back. So the area of a triangle is base times perpendicular height divide 2. Now we need to times that by 2 because there are 2 triangles in a triangular prism. Again, we're going to assume that this shape is closed. Okay, now there are 3 rectangles. So we have the rectangle at the bottom in green, so that is 6 by 12. We have the rectangle at the back of the shape in yellow here. That is 8 by 12, so we need to add that. Now we have one more one more rectangle to account for, and that's actually this rectangle here. So for this rectangle, we know the length, but we don't know the width. We don't know this dimension here. In fact, to find this, we need to use Pythagoras because it's a right-angled triangle. So x would just be the square root of, now it's the hypotenuse, so I add them, 6 squared plus 8 squared. And that equals 10, if you put that in your calculator. So this last rectangle is going to be 10 times 12, okay? So sometimes you will need to use Pythagoras to find unknown sides, and you might need those sides in order to help you calculate area or volume or whatever. So unfortunately, what makes triangular prisms difficult is sometimes all three of the rectangles will be the same size, have the same dimensions. Sometimes two of the three rectangles will have the same size. There are always three rectangles. In this case, each rectangle was a different size. You just have to be able to contend with that. Just find each rectangle one after the other. So let's put this on our calculator. And we should get 336. Again, it is square units. So what would the volume of this shape be? Well, it is a prism, so we find the area of the base and we times by the height. As I said before, the base is a triangle, not a rectangle. So the area of the base is 6 times 8 over 2, which we did before. Base times height over 2 for a triangle. And then we times that by the perpendicular height of the prism. So it's the height of the prism, not the height of the triangular base. So that would be 24 times 12, which is 288 centimeters cubed. And as we saw before, that means it holds 288 milliliters. So the last thing we need to do is look at a composite shape. So we're going to find the total surface area and volume of this composite prism. So a composite prism is either two prisms stuck together or one prism cut out of another. So the total surface area is a lot more challenging than the volume here. So to find the total surface area, so we have a cube with a cylinder cut out. So we'll find the surface area of the cube. So there are 6 faces, and each of the 6 faces is a square with area 6 squared. So that's the surface area of the cube. Now we have to account for the cylinder cut out. So what would be the total surface area of a cylinder? So it is basically a circular prism. So what it actually is 2 circles with a rectangle attached. Okay, that's what the net would look like. So if you have the radius of a circle, remember the area of that is pi r squared, but there are 2 of them. So the 2 circles gives you 2 pi r squared. So the rectangle in the middle, its length is just the circumference of the circle. So that's 2 pi r, circumference of a circle, and its height is just whatever the height of the prism is. So the surface area of a cylinder is 2 pi r squared plus length times width. 2 pi r squared plus 2 pi r h. So in this shape, we would need to subtract the 2 circles, one cut out of the top and one cut out of the bottom because it's a hollow prism. So we need to subtract 2 lots of circles, 2 times pi times, if the diameter is 4, the radius is 2. But there'd be inside the shape the curved surface of the cylinder. We'd have to add that on. That's been added on. So we need to add 2 times pi times radius times height. We have to add that on in this case because it's an extra part to the cube, whereas we took the circles away. So if you put that on your calculator, you get about 266.27 meters squared. Again, it's square units for surface area. So when you have a composite prism, you just have to go and add up each surface one after the other. I know it's hard, but that's all we can do for total surface area. Now, volume is a lot easier because we don't need to account for which surfaces have been added, which have been taken away. Here we can just find the volume of the cube, which is very easy. The volume of a cube is just the side length cubed and minus the volume of the prism. So, sorry, I meant to say the volume of the cylinder. So we know the total surface area for the cylinder. The volume, because the cylinder is basically a circular prism, is just area of the base times the height. But the area of the base being a circle, is just pi r squared, area of circle times height. So here, the volume of the cylinder will be the area of the base, so pi times radius squared times the height. And we just put that on our calculator, and we get approximately 140.60 meters, and this will be cubed. So how many liters of liquid would that hold? Well, 1 meter cubed isn't a liter, it's actually 1,000 liters, or a kiloliter. So this thing would hold approximately 140,600 liters. So to get from there to there, I just times by 1,000. Okay, so I know that this wasn't an easy shape to find surface area or volume, but that's how you do composite prisms. Volume of composite prisms is a lot easier. You're either adding the volumes together or you're subtracting one volume from the other. Please make sure you're good with composite prisms. So that's all for surface area and volume. The very last thing I need to show you on the whole video is how to find a dimension of a shape. Okay, so sometimes what will happen is you'll be given the volume or surface area or area of a shape, and you have to find one of its dimensions, like a radius, height, length, width, whatever. So whenever that happens, set up an equation and then solve it. So that's what we're going to do here. So we have a cylindrical tank that holds 50,000 liters of water, 4 meters high. We'll find its radius. So because this is in meters, 4 meters high, we want to convert 50,000 liters into meters cubed. So remember, I told you before that 1 meter cubed is 1,000 liters. So if I want to go from liters to meters cubed, I divide by 1,000. So 50,000 liters is going to be 50 meters cubed. So remember, I told you before that the volume of a cylinder is area of the base being a circle, times the perpendicular height. So therefore, pi r squared h must equal 50. So we know that the height is 4. So I'm going to take my formula and change h to 4. Now I need to solve for the radius. So remember, of course, that when you're finding the volume of a prism, you don't have to account for whether it is open or closed. It is the same volume whether the top is there or the top is missing. Surface area would change if you take away the top, but this question is only concerning volume because 50,000 liters, it's in volume, not area. So let's find what R is. So we need to undo everything that's been done to R. Remember, we undo multiplication before we undo powers. So what I'm going to do is divide each side by 4. 50 divided by 4 is 12.5. So to get R squared by itself, I need to divide by pi. And then to get R, I need to square root this. So R will be the square root of 12.5 over pi. So if we square root that, we end up getting about 2, I guess to 2 decimal places. It's 1.99 meters. So the radius of this tank would have to be 1.99 meters if the volume is to be 50,000 litres. So that's how you would do any similar question where you're given the area, surface area, or volume, and you're told to find one of the dimensions like length, width, height, or whatever. Set up an equation and solve it. All right, I'm sorry for the long video. I know there's been a lot to cover. Please let me know if you have any questions. Best of luck studying. This has been the luckiest maths teacher in the world. Have a great day.